is generalized hints and tips. So this is generalized hints and tips on problems like number 1 on the 4A packet. Anytime, and I'm going to make up characters. This is not going to be Joe Ponder and his fabulous pumpkin. So anytime you have a person, they have a mass. So if this person has, and we're gonna put a surface under them. We're gonna make the floor red just so it shows up. If this person has a mass of, name a number.
12.
12.
No, we'll do odd. 13. I don't like 12.
13 kilograms. This is a very small person. This would be a child. If they have a mass of 13 kilograms, the force of gravity that is acting on them, and we're going to color this some other color. We'll do blue here. So if we do, this is just made up. If we do the force of gravity on them, it would be equal to their mass times acceleration due to gravity, or times g. And that would equal 13 kilograms times negative 9.81 meters per second squared. So the force of gravity on them is going to equal, okay, so the force of gravity on this imaginary person is negative 127.53 newtons. You could also say that the force of gravity on this person is 127.53 newtons downward. Doesn't matter. Now obviously our sig figs are not good there. Any time that we've got a person on a surface and they're neither sinking down through the surface or rising up into the air, the upward force on them has got to be equal to the downward force on them. So there is another force being exerted on them. Whoops. We'll do that. Let's move our mass. Oops. Okay, so there is also a force upward on them, and we haven't talked about what that's called yet, so we'll just call it the force upward for right now. It's normal force. I think they reference it briefly. We'll start to talk about it a lot more in a little bit. The force upward on them, if they're not rising or sinking, has to be equal to the negative of the force downward on them. Okay? Because we know that if they're not rising or sinking, they're not accelerating, so what's the net force on them? 0. So really what we're saying here is that, let me do this in my base color.
So if we use a negative for the bottom, we just use positive for the top?
Let's walk through this algebraically, just to make sure it's clear for everybody. So the net force is equal to the force up plus the force down. You can all accept that. Okay. The net force is equal to 0, which is equal to the force up plus the force down. And of course, force down is force of gravity. So force up is equal to the negative of the force down, or the force of gravity. Or you know, force up is the negative of the force of, either way, whether you say it one way or the other, it doesn't matter. They're equal and opposite.
So
Does that
if we
make
want to do negative force down, positive force up, the same number, we can do that?
Well, if this is your force down, in this particular case, and we say that the force up is equal to the negative of negative 127.53 newtons, then what's your force up? Yeah, 127.53 newtons.
We can just do it like that every time.
Yeah, yeah. Now, I would advise you to stick with the convention
Is that in newtons?
that forces down. Yeah, it's in newtons.
Well, no, I said so did newtons equal to meters times meters per second.
Yes, yes. And we'll do a quick factor. If we didn't already do the, I thought we did, but let's go through it again. So is that clear? Okay. Just to do the very fast dimensional analysis, F equals MA. Newtons equal kilograms times meters per second squared. 1 Newton is the force required to get 1 kilogram of mass accelerating at 1 meter per second squared.
Yes.
Yes. So that's the dimensional analysis. Okay, questions, comments, concerns? We'll pause this and see if we have more things that are needed. Okay, make sure that you have taken a look at number 4 on the 4A worksheet for tomorrow. Make sure you draw a picture to help you out. I'll give you this much.
You can't see anything.
I know.
Okay.
Okay, I will give you this much information.
Can we just make him a circle?
Yeah, you can make them just a circle, that's fine. And if you look at where the angle is, they make a 30-degree angle with the ceiling?
With the vertical.
The vertical.
Oh, with the vertical, okay. So, this is badly drawn then. Hold on, let me undo my vines.
So what if we made them straight down?
Well, that's not what the problem says.
It's 30 degrees.
30-degree angle with the
Oh,
vertical.
those make a 30 degree. I thought it was saying like with his arms.
Nope. So I want you to get into that and label as many things as you can on that problem before you walk in for tomorrow. That's it.